Hey, today we're moving on to solving equations that involve multiplication and division. And in our past couple of lessons, we've been working on solving equations that work with addition and subtraction. And we talked about how addition and subtraction are kind of opposites of each other, that they undo what's happening. If you're negative $3, you need to add $3 in order to be even. And vice versa, if you have 5 too many of something, you need to take 5 away in order to be even. Remember, our ultimate goal in solving an equation is to isolate that variable to find out what just plain x is. Whatever that variable is, we want to solve for just that, not x plus 2 or x minus 5. So the same thing holds true here when we're solving multiplication and division equations. And you can see our standard up here, solving equations in the form of px equals q, or p and q are given. So just like before, you're going to be given a number for these and you're solving for x. So we're going to go back to some algebra tiles here, and we can see one demonstrated here. We've got algebra tiles to represent the equation 2x equals 6. We've got 2 x's and we have 6 yellow squares. Now, the problem is we don't want 2 x's. It's 2 times x. Remember, whenever we have a number right next to a variable, that means multiplication. So I have 2 of them. I don't want 2 of them. So how do I get down to 1? I need to divide by 2. So I divide this into 2 groups. I divide this evenly into 2 groups. And when I do that, 2 divided by 2 is 1. 6 divided by 2 leaves you with 3. So I have x equals 3. That's what we want to continue to do. To undo multiplication, we need to divide by that number. So again, let's look at right here. I'm going to give us a little more room here. 2x equals 8. Again, when we model it, that's supposed to be my x. I know it's kind of short. I've got 2 x's, and then 1, 2, 3, 4, and it's going to help to line them up into even groups. You'll find over time it's a little easier. So now I've modeled it. I have 2 x's, I only want 1, so I'm going to divide it into 2 groups. So here's one group, here's another group, and it works out to have 2 even groups. When I divide by 2, how many is left in one group? I just have 1 x. When I divide all 8 into 2 groups, what's left in the one group? 1, 2, 3, 4. Therefore, x equals 4. How about here when I have 3 x's? So again, I'm going to go 1, 2, 3. And that's probably an important distinction that I didn't say to begin with. When we divide it by that number, suddenly we're not looking at the whole thing. We're looking at what ended up in each single group. So I've got 9 squares here. Notice that everything we're dealing with is positive at the moment. We're not dealing with anything negative. So I've got 3x is equal to 9. I don't want 3 x's, I want 1. So what am I going to have to divide by? You guessed it, 3. So 3x divided by 3 gives me each 3 different groups of 1. That's what I'm looking for. So I'm going to end up with 1x. And when I divide 9 into 3 groups, each group then contains 3. So x equals 3. Can we do this one without the algebra tiles? Yeah. Remember, we split it in half. We want to divide by 4, and I turn them into fractions then because that's a shortcut for division. So 4x divided by 4 leaves you with x. 12 divided by 4 leaves you with 3. Therefore, x equals 3. Good job. All right, so let's go ahead and summarize this. To undo multiplication, what do we do in order to undo multiplication? We divide. Remember, dividing is what is the opposite so to speak, of multiplication. So if we have something multiplied, we need to divide it in order to undo it. And remember, we're not worried about these properties at the moment. Then to undo division, the opposite of division back is multiplication. We multiply, M-U-L-T-I-P-L-Y, the same number from both sides of the equation. This is called the, again, we're not worried about it. This is what we want to do in order to help solve multiplication and division problems. So, moving on, we worked with algebra tiles yesterday. We did it at the beginning, but that's unrealistic in the grand scheme of things. We need to be moving on to showing it without it. So remember, we're going to be drawing this line separating the left and the right. Still, we're trying to keep that scale even. So if we have 5x equals 20, we split it in half. We want to get x by itself, so if I have 5 times x, I need to divide by 5. And again, over here, the fraction bar is a way to express division. You'll use a fraction bar in multiplication and division equations. So just like I talked about a second ago, it's just kind of a shortcut way to turn it into a fraction bar and show division. So 5x divided by 5, I have to do the same thing over here. 20 divided by 5. 5 divided by 5 leaves me with 1x. 20 divided by 5 equals 4. So let's go ahead and do the same thing down here. Again, I'm going to start by splitting a left and a right. I want n by itself, so what am I going to have to do? I have 4 times n right now. To undo multiplication, I need to divide. If I divide that side, I have to divide this side. 4n divided by 4 equals just plain 1n. 20 divided by 4 equals 5. Therefore, n equals 5. Again, first step, model the equation or split it in half when we're not using algebra tiles. Second step, isolate the variable. I need to get m by itself. Right now I have 3 times m. I want m all by itself, so I'm going to divide by 3, divide by 3. When I do that, I'm left with m equals 5 again. Wow. All right, here's a little trickier one. You'll see what I'm talking about in a minute. We'll divide it in half. I want to get m by itself, so I'm going to have to divide by 5, divide by 5. When I'm left, I have m on this side, and 8 doesn't divide by 5. Oops, really well. Is that okay? Yeah, we can have a fraction. I would change this back to an improper or to a mixed fraction personally. So my final answer would be m is equal to, remember we just say how many times can 5 go into 8 without going over? 1 time. What was left unused when we took 5 away 1 time? 3, and then 5 still remains our n. So 1 3/5. That's okay. It's okay to not have whole numbers all the time. That's what you're going to be getting into more and more. And depending on what the question is asking, it might need to be a decimal as well, and that's okay. Last but not least, we're moving on to a division equation, and that's exactly like the multiplication one. We're just, how do you undo division? We multiply. So here we have x divided by 7 is equal to 3. I don't want x divided by 7, so in order to undo divided by 7, I have to multiply by 7. When I multiply by 7, that isolates this x. 7 times 3 gives me 21. So again, let's try it here. T divided by 3. I don't want t divided by 3, so I'm going to multiply it times 3. And over here, I don't have a whole lot of room, but I'm going to multiply times 3. Over here, these cancel each other out, which leaves us with just t. Here, I might actually write it like this down here so I can get rid of this over here. 3 times 2 is 6. 3 times 9 is 27, so my 7 goes down and my 2 goes up. 3 times 1 is 3, plus 2 is 5. I've got 1 decimal place, so that means my answer has 1. So t equals 57.6. I'm going to rewrite that because I didn't write it very nice. T equals 57.6. All right, over here, let's do it again. We got the variable on the right side this time. Does that change anything? I hope you answered a big old no, because it doesn't matter which side it's on. We're going to do the same thing. I'm going to multiply times 3 over here, which means I need to multiply times 3 over here. C divided by 3 times 3 leaves me with just C all by itself. 45 times 3, I don't know if you're able to do that in your head or not. If not, take the time to write it out. You should have ended up with 135. And I'm going to let you do this last one on your own. I'll check it tomorrow in class. Have a great night, and we'll see you tomorrow.